Hey there, this is Jingrui Yang, and the net ID is JY2823. The first video is about the first question of 3.8 of homework, the second homework. From the given information, we've known a causal linear time invariant system of h of z equals 1 minus z to power minus 1 over 1 plus 3 over 4 multiply z to power minus 1. And we also get a input of x of n equals 1 over 3 to power of n multiply un of n and plus un of minus n minus 1. The first question asks us to find the impulse response of the system Hn. We've known the z transform of small h of n. It's here. So according to the inverse transform, we can see this formula, and of course it's clearly that we should multiply one more z to this formula, and we get this one. And this one, we know that when we do the inverse transformation, we need the denominator to be z, but in this formula we also got a minus 1, so we can expand this formula into this kind of style, so that for the first one we've got a typical type of to do the inverse transform. And for this one, from the time shift theorem, we know that with the multiplicand of z to power minus 1, we can do the time shift, which like you can see at here. So we've got the first formula to do the inverse transform. We can get this one, of course, because the a is minus 3 over 4, so we got minus 3 over 4 to power of n multiply un. And for this one, we don't see the z to power minus 1, we got the same formula, but as I've talked before, that we should do the time shift. So here we shift the n to n minus 1, so we get the second section. So this is the small h of z. And for the second question, we've asked to find the output yn. In this kind of system, we know that the output, the z transform of output y, the output y of n should be the convolution of x of n and h of n. But the calculation will be so complicated, so we can try another method do the multiplication of the transformation of x of n and h of n, so that we can get the big y of big Y. It is the z transformation of small y, the output, and then do the inverse transform to get the small y. That's what we've asked to do. So the big X, according to what we've given, the big S should be like this. And oh, I forgot to talk about the ROC for question A. According to our formula, and also we've known that the system is causal, so the ROC should be the module of z is larger than 3 over 4. So the same thing for the question B. The ROC can be get from here. So it should be larger than 1/3 and smaller than 1. And get there. And y, big Y of z should be big X of z multiply big H of z. And we got the answer. Because the y's ROC should be the intersection of x and h. So from here, and we've known the ROC of HC, so we get the new ROC of y should be modulo z larger than 3/4. And with the yz, we can also expand this formula into this style and to calculate C1 and C2. For C1, we just take z as 1/3 and put this z into this section with the numerator of yz, and another part of C1, because for C1 z should be 1/3. So for this section, we just take z equals 1/3 into the plus 3/4. So we get the C1 and also C2, so that we can make the yz to this kind of style. With that, we can do the inverse transform and get the yn. It's the same as what we get hz here. hn, I'm sorry. Okay, then the question C, it is stable because according to the formula, the letter ROC, we know that the ROC should contain a unit circle. Every time when the ROC contains a unit circle, it is stable. So this question is solved.